Okay, in this class we're going to be running the moderation with process. So let's check what we have. We still have the five factors, right? The composites, and we're using those. This is just an example. This is nothing that was published, and I even don't remember what the factors were about. But it's something that it might work, not be the best example for, like perfect stats, but it's enough for learning reasons. So where we go, same story. We're going to analyze, and it's under regression. I have two different versions of process. If you have like installed like that, just use the latest one. Um, as you guys remember, process uses models. So number four, it was for the basic mediation, and number one is for the basic moderation. So that inverted T shape, right? X influencing Y, and the moderator is influencing the beta. So it's the arrow going straight to the middle of the X influencing Y arrow, right? So this is model number one for process. Of course, I don't remember all the the 92 models. Which ones I remember? I remember the one and four. Four basic mediation, one basic moderation. Anything different than that, you needed to go online and check the other models. It's just like a putting their process macro models template, and then you're going to have like a PDF with all the different templates, but most often we're using 1 and 4. In terms of our model, we're checking using, as I said, the data hub 2. We're going to test something like um, factor 2 influencing factor 3. So x influencing y. X is going to be factor 2. Factor 3 is our y. So we have here 2 influencing 3. And in terms of the moderator, okay, we're going to be using factor 4. Again, guys, this is just an example. In case if you would be doing this for your own research, you would have, your own factors related, theoretically related, and all that. Here's just like something that works. As I said, it's not like something outstanding, amazing, but it works. It's enough for us to see, some effects or how it looks like in terms of the analysis. This is going to be not under mediator or mediators, is under moderator. A process will analyze only one y, only one x, and only one, in the case here is a w, but this is the moderator, only one at a time. Again, you are you are running this as you're running this as support for your structure equation modeling. So probably you're not going to be using process for papers, you're going to use SEM, but this is just like a fast way to get the results. And then if you have something here to investigate further, then you go to SEM and do it there. That's it. You have the slides right there. All the material in the slides. You're going to have like the options. So once again, strongly recommend keep taking notes. Put the notes alongside the slides. Um, we need Bootstrap. Okay, and we don't need to save our bootstrap. The number of bootstrap is going to be 5,000. Keep in mind that the results might slightly be different, and it depends on which number the bootstrap starts, and then it's random, so the results might slightly different every time you do this analysis, and not changing if the computer will pick the same starting number, then they will replicate, but most often the starting number, it tends to vary, and so it's all good if it does not replicate. In terms of options, we have a few options here that we need to cover. We don't need the covariance matrix. We needed to generate the code for visualizing interactions. As you remember from the lecture, you need to plot if we have an interaction, okay? See here, show total effect. Well, you know that total effect is for mediation only. Pairwise contrasts, you don't need that. But you need a test for X by M interactions because we're dealing with interactions. Remember the interaction term? The good thing about process, and this is what saves us a lot of time before modeling in Amos, is that process will calculate the interactions for us. Okay, so it's calculating here the interaction of factor 2 and 4, and you see this on the results. What else here? We needed to center. Remember, we were talking about centering. Centering is just to make the output more beautiful, so we can understand better the numbers, sorry. So yes, we click on that. The probe interactions, it will usually come for a P of 0.10. Remember that we were discussing about different types of P, different strengths or different stars, different levels. So this is the least one acceptable, 0.10. I don't know why 0.20. Have no idea. I've never seen this in my life. 0.20. Usually you're going to see like 0.10, 0.05. Those two tend to be 1 star, right? This is more in business and marketing. This is psychology. They don't accept anything above 0.05. And then you have 2 stars, 0.01, and of course you have 001. I usually, for conditioning here, or anything that we're doing here, instead of percentiles, I usually try to ask output giving the mean and standard deviations. So we just check that, and this is another layer of information in case if we need. It's just another test, okay? It's good to have, but we don't need that, to be honest. I'll keep the decimals as 4 for now, but later if you want to change, you can change to 3 or 2. I'll hit continue. And guys, that's pretty much about it, we can check for long names. I accept the risk of incorrect output. You remember the incorrect output is just like the way the software is going to shorten the name of the variable, but the results is just like the same, just to avoid an error, because factor 5 or number, right, underscore C is 2, 4, 6, yeah, it's about 8 or 9. Long variable names, okay, that's it. Okay, we hit OK, and then we should get the output. Here's our output window, and what we have here. As the mediation, we need to check step by step. We have W, that's the moderator. We have X is factor 2. We have a Y is factor 0.3, so 2 influencing 3, and then the size, the sample sizes, the same we had with the data cleaned. In terms of the outcome variable, so we have here our y. Y is factor 3. So we have factor 2 influencing factor 3. We wanted that. This is x influencing y. The coefficient for that is 0.29. Okay. So it's positive. It's kind of, showing like there's some value happening. Remember that for business marketing, we're looking more or less to the coefficients in between point 15, 20, 20ish is like you have some effect there for sure, and they tend to be up to 50s or sometimes 60s if it's very strong. But we don't interpret these coefficients, as I said so many times. We'll be checking if this is in the direction we want. So in this case, it's like a positive directional effect of factor 2 influencing factor 3. Sweet. With a t-value above 196, it is 5.19, and the p-value very tiny, very low, 0.00000, and it would go and on and on. Sweet. So we know we have this relationship happening. Awesome. As you might remember from the lecture, the way the software calculates, the way we calculate moderation, we need also to check the influence of the moderator. This is, a procedure only. It's not something that you need to anticipate hypothesis. So we have factor 4 influencing factor 3. This one, it could be or could not be statistical significance, is all good. We have it is a 0.26 above 196 for t-value, p very very low, so statistical significance, sweet. But this does not give us anything yet. This guy here is going to give us what we are looking for. Is actually the interaction. So the interaction, look at the product term key. It multiplied, just as I explained in the lecture, the factor 2 or our x by factor 4, our moderator. So we have this multiplication happening here, the interaction between x and the moderator, and this was regressed on our y factor 3. So interaction 1 on factor 3 is a negative relationship of 0.06, very tiny. However, look, is above 0.96 negative? Yes, because it's an absolute value of 196. It could be positive and could be negative. As you'll notice by the p-value, is borderline with 0.05, but we accept that as statistically significant. Very tiny, very small, but it's happening, right? Sweet. What else? Then you have here the conditional effects is just like the changes, okay? And then you can see here even better various the score is negative and it's growing and approaching like positive values, so it's like a a growing exponential, not exponentially, but it's a growing pattern right there. And then you have the effect also changing, so are the t-values and the p-values. Okay, so we can get like for each point here. This is the Johnson-Neyman method we asked. This is just for our curiosity. We're not going to be reporting that. We also asked this. We asked, remember, we asked to generate the code for visualizing interactions. This is the one, okay? And it will plot for us. What else we have here? Um, we have the bootstraps for the regression. We don't need that. That the number of bootstrap sampling was 5,000. The confidence interval is 95%. We needed this. So how we're going to be plotting our our data and our results? We just double click and then we're able to select stuff. And we want to select everything here. Take a look up to the, the final object in there. This is just like this. Here, Control C, or I think a copy will work. Yes, it will work. And then what? We're going to File, New, and you want like a new syntax. Once you have the new syntax, is this dialog box, you're just going to paste Control V. So exactly the same. It starts with the data list free and goes up to, the end of the line right there. So we're not forgetting to copy anything. We're not going beyond that. So it's just this information right here, right? You get like an enter here, an enter right there. So it's making it even easier for us to select the whole thing. Sweet. We now select everything. Once you have it selected, it's just a matter of click run or play. Okay, boom. And it should prepare us the plot. All right. Few things first. In terms of the plot, okay, we're not going to be using this plot as well for our papers. You needed to draw that in high resolution. So you're going to be using this as your guideline. So you're going to be putting this later on in any software that you use for drawing, and then just to draw over it. Okay, just like change the opacity of the figure, because this is going to be a figure anyways exported. You can print screen, change the opacity, and then just draw over it. So it's going to be the same lines, so you're not kind of replicating the lines. They're exactly the same lines, exactly everything. The only thing we're doing here, we're just making sure we have in the highest resolution as possible. And this resolution here is not enough for for as a journal submission. You double click and then you have access to the options for formatting the your plot, your figure. Nothing much we can do here. There's like you can keep clicking and stuff. Mainly what we want to remove, okay, you want to remove here the grid. Is just this option here, show, and oops, here it goes. We don't want that. And if you click in this one, interpolation line, it will draw for you. Connect to the dots right there. It will add another thing in here that we don't want. Later on, you need to delete that in the software. See, it puts here interpolation line. We don't want that. We don't report this in a paper. But it's good for us to have this already. So in any other software we're using for editing our plot, you have it ready to go. So as I said, you're going to just draw over it, so you have the axis already and etc. Okay, you're going to change here. For changing, if you want to change here, it's just a matter of clicking, and then you have access to that. See, you can already select stuff and etc. It's kind of, oh, here goes. And then you can change the names and all that. In the slides, I'll bring the slideshow right here. I put it there just like, that you needed to follow the guidelines of the journal that you're using, and some of them they will slightly change. For example, the anchors here, you might not use all those anchors, you might use only the low and high values, or low, mean, and high. It's just a matter of labeling. I would do all of that in a software, not in here. I would only use this as a template so I could further, draw and keeping like the lines in the same steepness as they were originally. So you're not kind of, drawing on your own. You have those guidelines, but this is not going to be exported from SPSS. I put here an example of of two of two plots, and as you see, they're just exactly as the ones we had there and the one we had there in SPSS, just formatted. So we have low, average, high, and the levels of AGCC. As you'll notice here, is not very sharp, but this was a problem when they were processing the paper. This is the one uh, published in 2019 in the Journal of Global Marketing. There are a few plots in there. And how you read that? Same story. Guys, this is the moderator, impulsive buying, AGCC, so you have your axes, okay, X and Y, low levels of the mediator, average levels, and high levels of the moderator. It means that for high levels of attitudes towards advertising, that's our moderator. High levels of moderator, you would have here, again, we're checking the points. For low levels of AGCC, the person would have a positive, looks that it goes from positive to negative, so a positive level of impulsive buying. This is the main, okay? For average levels of AGCC, sorry, you would have slightly higher levels of impulsive buying, high levels of AGCC, higher, because take a look, it's going up. In terms of the steepness, is not very aggressive, let's say, as this one here. Look at the change of that. So this one is very strong. You can feel it's very pronounced. This change in slope, less pronounced and way less pronounced. So this is for high levels of moderator. As in high levels of the moderator, we notice that there is a change in the beta, okay, but is not as pronounced as in high levels or sorry, in low levels and mid levels of the moderator. Same here, look at this one. This is very pronounced for high levels, mid levels, and even more for low levels of the moderator. Same story. You're reading by the points, connected the points. And high right there and here, see? And strongly recommend you guys give a check to this paper, okay, and see how it was there in terms of the discussion of the paper, how you discuss that. And not only that, how you put the hypothesis and how you explain first the directional relationships. You need to cover the direct first. X influencing Y. Okay, so you have the X and Y axis here, and then you have the moderator right there. And then if we get or X influencing Y, and if we have our interaction term statistically significant, we plot, and then from the plot we're going to be, drawing our conclusions. So if we get back to our plot here, as you notice, our interaction, let's go back there. Our interaction was a negative 0.06, and this is reflected right here. If you have like a stronger effect there, if negative or positive, I mean just stronger in terms of the number, the coefficient, then you're going to see more pronounced those lines and the relationships. But once again, you're not inferring like a from here, okay, from factor 4 or the interaction. Your conclusions, they come from the plot. So once again, it's a three-step thing. You check X and Y. Statistically significant? Yes. Good. So I can move forward and then proceed with a moderation test. Was my interaction term statistically significant, influencing the output or our Y? No. So you don't have moderation. Yes, it was. I have moderation. I needed to plot. You plot. And then based on, the output you have, you're going to draw your interpretation. So here, as you'll notice, it's giving us in colors. As I said, you're not keeping those colors because papers are going to be published black and white. So you're going to get rid of those, those points, and you're going to be using the lines. You need to draw those lines yourself, as you know that already. But here you have low levels, average, and high levels because it's giving us, based on the mean. Okay, the standard deviation and the mean. So anyways, you see there's a negative, so okay, I know that is going from low, mid, and high. Again, low, mid, and high. I wouldn't keep those numbers here. They're not informative at all. Okay, they're just you just needed to say that low levels of X, average levels, and high levels. So put more or less where you see the one here, a high, average, low, and then you have here the mean for the for our Y. Those you should keep those numbers. 5.40, 17, etc. That's why it's good to have this plot when you're drawing, because you're keeping exactly the same, the same position. So you're not just like randomly putting 40, 70, because they're the proportions right here. This is ready to go. As I said, you're just using this as your template so you can have it in very high quality. Then you can clear that, put your own, you needed to delete these right here. You needed to delete those dots right there. Can you do it all here? Yes, yes, you can. You're going to be clicking, clicking, clicking until you get rid of everything and adjust the way you want. It will take probably more time, and and apart from that, once you save this figure, it will not be in high resolution. Then probably If the journal article is accepted and your research paper is accepted, the editorial team of the journal will ask you anyways for a high resolution. So it would be faster if you use like any other software for editing, like a GIMP, and that's a free software for editing images, or any other software that you have right there. And that's how we do it in Process. You'll notice that's going to be similar, but yet different when you put in structural equation modeling, because there you got the model fits, you got like a latent variables, but having a result here will save you time once you're implementing there. So as I said, it's good to give it a quick check here, and then you implement in SEM, and probably you're going to be reporting only the SEM and use the process for your personal, data mining, and check if it was worth moving forward. Okay, and that's it for the process.